Alright, welcome back everyone, it's Kabir Bhutto here. In this lecture we are going to solve this problem which is related to moment of inertia. Before solving this problem, I would really suggest you to go through my previous lectures related to moment of inertia to understand the basic concepts of this topic. I've added the links to those lectures in the description below. Okay, let's start. So we have to determine moment of inertia about this axis as well as this axis and their corresponding radius of gyration. And the moment of inertia and radius of gyration are to be calculated for this area, purple area, limited by this curve or this function y is equal to 64 minus x squared divided by 25. So let's first calculate Ix. In these types of question where you have an area limited by a curve or defined by a curve, you need to draw a strip parallel to those axes about which the moment of inertia is to be determined. So if I want to determine moment of inertia about x-axis, I'm going to draw a strip parallel to it. Whereas if you want to determine moment of inertia about y-axis, just draw a strip parallel to it. So first calculating Ix. We know that Ix is equal to under root y square dA. As I'm calculating moment of inertia about x-axis, I'm going to draw a strip parallel to this axis. So this area is our differential area dA, and the height of this differential element is equal to dy. And this differential element touches the curve at 2 points, this one and this one. Coordinates of this point will be minus x comma y, whereas this coordinate will be x comma y. This point lies in positive x and positive y, hence both are positive, and this point lies in negative x and positive y. And if I calculate dA from here, dA is the area of this rectangular element, small rectangular element. The width of this rectangle is equal to 2x. This is x, and this distance is also x. So dA from here is equal to 2x into height of this rectangle, which is dy. So if I insert dA here, y square 2x into dy. Solve this equation for x. Y is equal to 64 minus x squared divided by 25. So solve for x, you'll get x from here is equal to under root minus 25y plus 1600. So just substitute this value of x here. Substitute this value of x here. Ix becomes now we just need to solve it. And what will be the lower and upper limit for this integral? So this area starts from 0 here, and in vertical direction it goes up till 64. So the lower limit will be 0 and upper limit will be 64. Now you can use the scientific calculator to get the value of this whole term. Alright, using calculator to determine the value, 2 integral alpha x square and then square root minus 25y. So here it will be 25x minus 25x plus 1600. Lower limit is 0 and upper limit is 64. Press equals to, and your answer is equals to 319,5660.190. .190. And unit of moment of inertia is millimeter power 4. And this is your answer. Alright, now let's calculate Iy in a similar manner. So let's first draw a strip parallel to this y-axis. So this is our differential area, and the width of this differential element is equal to dx. And we know that the generalized form or equation for Iy is equal to integral x square dA. And the coordinates of the point where the differential element intersects with the curve is x comma y. And if I calculate dA from here, base of this rectangle is dx and height of this rectangle is dA is equal to y dx, x square y dx. And we have to integrate with respect to dx element, so we need to convert this y into x. And how we are going to do that? You are going to use this relation here, x square, and just substitute the value of y from this equation, 64 x squared divided by 25 into dx. And the upper and lower limit will be corresponding to x direction, since we are integrating with respect to dx. X is 0 here, and minus 40 here, and positive 40 here. So the lower limit in this case is going to be minus 40, upper limit is going to be plus 40. And if you simplify it, after integrating it, apply limits to it. Alright, if you solve this, Iy is equal to 1092266.67 millimeter to the power 4. And up till here we have calculated the moment of inertia about x and y axis. Now we just have to evaluate the values of radii of gyration about x and y axis. Remember that radius of gyration is equal to square root of moment of inertia divided by area. And if you want radius of gyration about x-axis, Rx in that case is equal to under root Ix divided by A. Similarly, following this, Ri is going to be equal to Iy divided by A. So previously we have calculated Ix and Iy. We just need to calculate the area of this plane figure. And to calculate area, we are just going to integrate this function with respect to dx. And A is equal to integral 64 minus x squared divided by 25. And if I assume a strip here, and this is dx, so the upper and lower limit will be corresponding to this dx element. Lower limit will be minus 40, upper limit will be 40 into dx. And if you integrate it, solve it, 3413.3 millimeter to the power 2. And let's just substitute the values and calculate Rx and Ri. So Rx is equal to under root Ix, which is 3195660.190 divided by the area under the curve, 3413.33. Rx is equal to 30.597, and the unit of radius of gyration is millimeter to the power 1 millimeter. Ry is equal to under root Iy, which is 1092266.67 divided by area, and it's equal to 17.88 millimeter. One last thing to discuss: how is the unit of radius of gyration equals to millimeter? So if you look here, this moment of inertia is a unit of millimeter to the power 4, whereas area has a unit of millimeter to the power 2, and this becomes, if you solve it, millimeter to the power 2. And notice here we are taking square root, and if you take square root, this becomes millimeter. And this is how the unit of radius of gyration is some unit of length. It could be in inches, feet, or millimeter. And we are done with this lecture. Thanks for watching till the end, and take care.